everyone, welcome back to Tech is Strong with Shobhit, where we break down complex engineering concepts so simply that even your non-tech friends will understand them. Today, we are starting a brand new series called From Code to Silicon. This is your complete roadmap to low-level engineering. We are going to find out how the code you write actually runs on the metal. The big misunderstanding. When people start learning to program, they usually think writing the syntax is the hard part. But that is just the tip of the iceberg. Real magic happens underneath. When your logical code transforms into tiny electrical signals inside the CPU. Today, you are not just going to learn how to code, you are going to learn how a computer actually thinks. Code versus reality. Let's look at the simple example. When you write int a equals to 10, it looks clean, it is readable, it is friendly. But to a CPU, this text means absolutely nothing. A CPU does not understand English, it does not understand C, Python, or Java. It is a piece of rock that barely understands electricity. It only speaks machine code binary. So, your job as an engineer is not just to write code, it is to understand the journey that code takes to become hardware instruction. The four-stage journey. That journey happens in a specific pipeline before your code ever runs. It goes through four distinct stages: pre-processing, compilation, assembling, and linking. Let's break down these because most developers ignore these, and that is a huge mistake. Stage one is pre-processing. This is the cleanup crew. It strip out your comments, expand your macros as shown in top of the slide, and pulls in headers file. Fun fact, your code actually gets bigger in this stage. Stage two is compilation. This is the heavy lifter. It converts your C code into assembly. Assembly is the bridge. It is still readable by human, barely, but it maps one to one with what the hardware is about to do. Stage three is assembling. The assembler takes that text-based assembly and translate it into pure machine code, ones and zeros. But we are not done. We have stage four, linking. Your code uses libraries, right? stdio.h, math libraries, etc. The linker takes your binary and grab the code from these libraries and stitches them all together into one single file. This is your final executable inside the CPU. Okay, the file is ready. We load it into memory. What happened inside the CPU? CPU is made of three main parts you need to care about. Registers, tiny, ultra-fast storage slot, the ALU, the calculator that does math, the control unit, the traffic cop telling data where to go. Here is a secret. CPU does not understand your logic. It just execute primitive task really, really fast. Here is a proof. You write this, A equals to A plus 1. Simply write. But the CPU performs a dance. First, it loads the value of A from RAM into a register. Then the ALU add 1 to that register. Finally, it stores the new value back into RAM. Every single file of high level code you write turned into dozens of these micro operations. So, why I'm telling you this? Why not just write C, C++, Python, and be happy? Because if you want to get into embedded systems, firmware, high performance game developer, or security, you must understand this pipeline. This is the foundation for debugging complex crashes, writing drivers, reverse engineering malware, and squeezing every ounce of performance out of the chip. Low level engineering starts here. Now that you know how code runs, next time we are going to look at where it lives. In episode 2, we are deep diving into pointers and memory management, the concepts that scares most students but give you superpower as an engineer. If you found this helpful, smash the like button, drop a comment if you have a question, and subscribe. This series is going to transform the way you think about computer. See you in episode 2. Thank you.